Good morning, everybody, and welcome to ARC's web window this week on the topic of industrial 5G. This is David Humphrey. I'm an analyst with ARC Advisory Group based in Munich, and I'm very happy today to have my colleague Naresh, who's also based in Germany. He's over in Dresden, who will be sharing the half an hour presentation or so with me. If I can get to the right click, I'll go to the first slide. There we go. What we want to talk about today is, first of all, what is 5G versus industrial 5G? We're going to give some technical information, an overview of the 5G spectrum, the frequencies. We're going to talk about the three main communication services of 5G that really divide 5G into the three different bits of that 5G is together. We're going to talk about how private networks are the solution for industrial users. We'll mention a few applications, which is really nice to hear sometimes to get an idea of where 5G can make a difference. We have a huge list of activities going on in the industry with mergers, cooperations, alliances, and we'll mention some of those. And finally, we'll get to our recommendations. What is 5G? 5G is a means to a solution. Our initiatives that we've been talking about for going on 10 years now are things like Industry 4.0, the industrial IoT, smart factories. To make all of this work, what you need is a reliable communications backbone. And we have that to a large degree with our Ethernet technology that we've had in the world since the 1970s, so we've had in the factory for about 15 years now. We also have wireless technologies, but they haven't been used to a great extent, and certainly not for anything like control purposes. 5G is a real game changer, or it's going to be when it comes out. It is the latest generation of the mobile wireless communication standard. It's obviously the successor to 3G and 4G. It provides a fast and modern communications background, as I mentioned. It promises significant improvements in performance, but as you'll find out in this webinar, it's more than just a faster horse. It's more than just a faster network. It opens up possibilities that weren't possible in the past. And in our view, it's truly a game changer and a very important enabler of the initiatives I mentioned above, like Industrial 4.0. We have to get into the details a little bit. I want to ask my colleague, first of all, Naresh, welcome. I want to ask Naresh to take over and to give us an overview of the 5G spectrum. Naresh?
Thanks, David, for such a nice introduction. Hello, everybody. This is Naresh, based out of Dresden in Germany. I'm going to talk about 5G spectrum, global overview on spectrum bands and also on private networks. The first most important element in 5G is the spectrum. And spectrum is a critical element and the top concern for network operators and network infrastructure vendors and even industrial companies in this 5G era. As many of you might be aware that unlike 4G technologies that are offered only in low band frequencies, 5G technologies are now available with mixed spectrum frequency bands as shown in this graphic. Looking at the frequency bands, 3GPP, the Global Mobile Communication Standards Organization, has divided 5G spectrum into two specific 5G NR, which means new radio bands, frequency 1, starting from 410 megahertz up to 7 gigahertz, and frequency 2, about 24 gigahertz to 52 gigahertz. But spectrum is seen or denoted as three different bands in the market, including low band, mid band, and high bands. The main differences in these three bands revolve around network coverage and capacity and bandwidth and speed. And when we look at low bands, which are used for applications that do not deal with high data volumes but need a good coverage over the long distances, for example, in mining or electric power and transmission distribution applications, and maybe even in oil and gas field. And when we look at high bands, which are used for applications where data volumes are high, for example, transferring 4K or 8K videos for gaming applications, as these bands are capable of carrying high data. For our recent industrial 5G research, we found that majority of industrial companies seem to prefer low and mid-band frequencies, as these bands offer both needed coverage and capacity compared with high bands. But However, in any case, telecom operators will have to combine low, mid, and high bands to give the performance the users expect, whether it's for augmented reality or virtual reality or low data carry sensor networks or any other enterprise use cases. Telecom operators will have to combine mixed frequency bands in their portfolio. Looking at global overview of 5G deployments, the 5G cycle has already begun with 5G radio access network upgrades since the beginning of the 2018. The first movers in the market are the South Korea, China, and the US, and even Japan, and lately followed by some of the EU nations. Over 200 network operators already hold licenses for 5G bands globally, and about 100, I think nearly 100 commercial 5G networks are on in about 35 countries by end of August 2020. Also, when we look at into new 5G devices, I mean the end devices like 5G routers or 5G chips with the different form factors are even increasing in the market. When we look at into global overview of spectrum, the US already concluded 4 auctions on 5G spectrum. 3 of them are on high bands and 1 is on the mid band. And Germany started issuing licenses for mid bands since 2019, and allocation of high bands are under consultation. And Japan also started issuing licenses in high bands since 2019 and expected to release licenses for mid bands by end 2020. If you look at allocated bands, USA, Korea, and Japan, they are initially focused on high band frequencies, whereas Europe is more focused on mid bands. Today's topic is 5G in industry, which means 5G for private use. When we look at that scenario, US very recently, which means in the first week of September, the auction 105 was concluded on issuing priority access license, which is part of CBRS spectrum for private users. And priority access license used by provided by through communication service providers who license a portion of the band to private users. But when we look at into Germany, Germany reserved 100 megahertz of spectrum in the 3.7 till 3.8, which means mid bands for private companies. And I think about 30 companies have already bought licenses for the private use. But when we look at into France, France located 5G bands for 4 different communication service providers in France with a leasing option. And also France has allocated a small, 50 megahertz frequency for the airport for a private usage. The key takeaway from here is each country has its own approach in allocating 5G bands, and regulations or policies are vary country to country. Some countries want to offer spectrum directly to the enterprises for private usage, and some countries offer spectrum only through telecom operators. And some have mixed approaches. This is how the spectrum has been managed globally. I think with that, I pass on to my colleague David to talk about communication services.
All right, thanks, Naresh. So what is 5G? 5G is pretty much divided into 3 parts, not all of which are available right now. We call these parts communication services. They use different frequencies. They include different protocols, different mechanisms for communicating. The first one that is available right now is part of the release number 16 that just came out in July. This is enhanced mobile broadband. Let me go to my next slide because I have more details on it. There we go. Enhanced mobile broadband, as you see, just came out. This is the version of 5G that you can get in your mobile phone today. I think Samsung phones have had 5G for a short time, and if you're a fan of the iPhone like I am, I plan to probably get the iPhone 12 when it comes out next month, and that's going to have 5G. 5G in the iPhone will be nice, but it'll just be a faster horse. In other words, you can expect maybe a 10 or 20 times faster data transmission rate, but for the way that we use our cell phones, it's not going to make a big difference. You'll probably notice it somewhat, but again, it's just a speed bump or a performance improvement. For industrial users, like most of us are, the really interesting communication services in 5G are those that are going to come out with release 17, which is due out in early 2022. Those are the ultra-reliable, low-latency communication, very awkward names here and long acronyms, and the massive machine type communication. What's the difference? There's actually a very big difference between these two. For industrial users, especially factory automation applications where I have some sort of high-speed process where I'm doing maybe closed-loop control, for example, in motion control, this is the answer. If you can imagine doing closed-loop control over a wireless connection, which nobody really has done, this will be the solution. The key here is low latency, and most of all, a guaranteed latency of something under one millisecond. What will this be good for? The applications that we can imagine are logistics applications like AG fees, anything that moves in the factory that needs to be coordinated in real time. Certainly applications that are coming more and more like augmented reality, where you're transmitting a fair amount of data to operators walking around the facility, so where they need a wireless connection. And as I mentioned, if you dare, then you can use it for closed loop control. The first time that we would ever replace a copper cable with airwaves. The third type of communication service for 5G is this massive machine type communication. This is communication over a wide area. In industrial applications, this could be an oil field, this could be field instruments that are located at great distances, but the application that really clarifies it for myself is smart cities. This is an entire city, modern cities like Barcelona that have invested a lot in smart city to connect every service, every sort of technology that runs the city, from traffic management to lighting in parks and buildings. Also smart metering. Last week I got my card from the electric company that I have to fill out to enter the number on my electric meter in my basement. And in the future, that meter could be read using this communication service, massive machine type communication over 5G. It'll be up to eventually industrial users to choose the service that is most appropriate for the application. And as you can see, there are three very different applications. Put them all together, A plus B plus C, and you get 5G communication services. All right, I'm going to pass the baton back to Naresh, and Naresh is going to tell us why private networks for 5G are the solution for industrial users.
Thanks, David. When we look at 5G network deployments for industry usage, one of the most important variables is the subject of public versus private networks. Private networks are referred as non-public networks, in small abbreviation NPN by 3GPP. At the moment, private networks are offered with two main deployment models in the market. One is a standalone private networks, and the second one is a private network in conjunction with public networks. Next slide, please, David. I have pictures there so that I can easily explain how the deployments look like. Thank you. When we look into standalone private networks, the network is deployed as an independent standalone network with a dedicated spectrum in user premises. And all network functions are located inside the defined user premises, for example, an industrial site or a manufacturing factory, or maybe a campus. And the network is isolated from the public network. However, these networks are also enabled with connectivity provisions to public networks for roaming services, which is a very key task to be done when standalone private networks are deployed. In this model, enterprises can acquire their own spectrum license from the governing body or from a communication service provider or telecom operator that offers a spectrum on lease basis, which we just discussed in the frequency band section. When we look at private networks in conjunction with public networks, we see three different deployment models, and one is shared RAN and control plane and hosted network. When we look at the shared RAN, a private network and the public network share a part of a radio access network, and the network has its own private network ID with an agreement from a public network provider on RAN sharing agreement. And when we look at shared RAN and control plan, in this model, private network and public network share the radio access network and core network control plane, which is hosted in a public network. This model is implemented by means of network slicing. The last one is the private network hosted by a public network. This is very cost-effective model. And in this scenario, the private network traffic is external and external, which means which is not in the defined premises but treated as completely different network from public network. This is achieved by means of through software defined networking and virtualization of network functions in a cloud environment, and this is very cost effective model compared with any other models here. And as per our research, enterprises are increasingly looking at private networks to enable them to have full control over networking solutions that have the characteristics that they need for their business purposes or maybe their use cases. Most of the large sized enterprises, maybe large chemical plants or oil and gas plants, or maybe in the mining areas, seem to be interested in standalone private networks, and medium sized enterprises seem to be interested in cost effective models, any of these three models. However, I mean, the deployment models depended on the budgets and the network infrastructure vendor availability and the spectrum availability. For example, deployments of private network models completely vary from country to country, as some countries allocate spectrum for enterprises for their private use, and some standalone private network models are not possible in some other countries because countries do not want to offer spectrum to the private companies, only to offer spectrum to the communication service providers on a lease basis. So in such cases, standalone private networks may not be possible in some other countries. With that, I think I pass on to my colleague David to speak about possible applications.
Thanks for the bounce back. In my previous slides, I talked about some applications that support the three different, or are supported by the three different communication services. I want to go a little bit deeper into the applications that are really relevant for industrial users. And I've divided a set of possible applications that I can imagine into factory automation and process automation. And I'll just go over them briefly because they really are good examples to help us understand what 5G can do for us. And keep in mind that some of these applications can be and are solved today with copper wires. The difference for 5G will really be not the applications for which it can replace an existing technology, but the applications that it makes possible for the first time because of its speed and its bandwidth capability to connect many devices and also to provide the security that we need for our networks. So just starting at the top, certainly maintenance in any aspect. Maintenance means workers walking around the factory, and they can be holding a tablet, a handheld device. We're starting to see more and more augmented reality, that this is the idea that the worker wears a set of goggles and looks at the machine, and information that is important to his task, parameters or maybe even guidance of where to look around the machine to find a problem, are projected onto the lens of his glass. He sees through the glass, but he sees, if you have a heads-up display in your car, you know what I'm talking about. He sees additional information that enhances his view and makes his job easier. The distant cousin to augmented reality is virtual reality. This is the idea that pretty much everything is virtual. This is really useful in training. I've seen great solutions from a number of companies, from Honeywell, from Siemens, that create a whole virtual video game environment, but with a practical use. I don't think much of video games as far as practical use, except for increasing hand-eye coordination. But for virtual reality applications in training, you can teach your people how to walk through an entire process plant and teach them the steps of how to troubleshoot a problem, get to the source, maybe even guide them through hazardous environments. Virtual reality has a huge potential. It's being used now already, but it'll be greatly enhanced and greatly improved with a much better communications technology like 5G. I mentioned before, any sort of logistics. This could be robots, this could be automatic guided vehicles, this can also be rotating devices, it could be carousels like in a bottle filler, for which a cable connection is possible but difficult. Certainly information sharing and the classic peer-to-peer applications that we do today between controllers, between their devices and PCs. And as I mentioned before briefly, closed loop control. This one makes me a little nervous. I think of a printing machine that has those big rollers on it, and in the past was controlled by drives. The many rollers, the many axes were connected mechanically by chain drives, by mechanical couplers. We solve this problem today with servo axes, but they're connected by cables that are subjected to electromagnetic interference. if we could replace those with a reliable, fast wireless connection like 5G that allows us to get feedback and do closed loop control, that would be great. That would eliminate a lot of the EMF problems we have today. It might be a trade-off as far as cost. That remains to be seen. In the area of process automation, condition monitoring is the application of the day. Condition monitoring goes hand in hand with analytics. It's very important in the process industries where assets are very expensive, so it makes sense to invest in equipment that monitors parameters. Like the classic one is vibration, but there's also things like oil analysis or corrosion. These are typically or very often applications that are bolt-on or add-on. They're added after the fact to enhance the monitoring capabilities of an asset. And the best way to add on an application, if possible, is by wireless, because it avoids obviously running a cable out to the sensor. Plant asset management in general is one size larger in process automation. To that, I like to count not just condition or performance management of assets, but also maintenance management. And that's the application that I meant before. And then again, as I mentioned in the previous example with factory automation, autonomous logistics also play a big role in process automation. So I'm going to do one final bounce back to my colleague Naresh, and he's going to provide a litany of activities of what companies are doing out there. I've asked Naresh not to name and talk about everyone, although each of these stories is interesting, and instead to rather just give us a highlight of what's going on.
Thanks, David. I'll keep my promise. When we look into the current activities, despite COVID-19 pandemic, when we look at the acquisitions and partnerships, the companies like network infrastructure vendors and telecom operators and even software cloud providers and software companies and even front haul, back haul network specialized companies and chip manufacturers, all these companies pushing 5G, despite COVID-19 pandemic, pushing 5G, very aggressively. And as per our research, the 5G market looks very dynamic. And if you look at the acquisitions and software companies like Microsoft, a cloud native company, acquiring specialized cloud native software, virtualized network software companies. And if you look at frequency bands, T-Mobile, which had a low band frequencies, acquired Sprint recently in April. Sprint had Sprint owns some mid-band frequencies, and when the acquisition is complete, then T-Mobile has both bands and low band and mid band to compete in the US market. And when we look at into the automation companies, for example, Honeywell partnered with Verizon, offering smart meter, smart connectivity solutions in the electricity area and transmission distribution. And when we look at into Europe, the market is pretty much same like in the US, but we see companies like telecom companies more on partnering with Amazon Web Services. The main idea is to bring ultra low latency services to the plant with multi-access edge computing, or also called mobile edge computing applications in the Europe area. And one more key takeaway from the Europe is, if you look at Siemens and ABB, these two companies have already, started on 5G activities, and they first installed the 5G standalone network, by Siemens with Qualcomm. And ABB also working with Ericsson. They already started a 5G industrial innovation lab. And when we look at these two, in the Europe, the market is moving towards industrial domain, for example, automation, maybe in the automotive area, something like that. We see that pattern in the Europe side. When we look at it in Asia, it's kind of a mixture of both industry side and also as electric power and distribution side as well. Even mining applications have been moving on. And when we look at into Asia, Nokia and NTT Docomo, and these companies are partnered with automation companies like Omron, Hitachi, and so on. So we wanted to also give a brief look on what are the project announcements, which are the major industries, the initial adopters of industrial 5G. Then when we look at into recent announcements by major infrastructure companies or telecom companies, then we look at into Europe, it's only one mining project we see here. But if you look at other projects, the Europe is more of moving on to discrete automation. The 5G is moving more on to discrete automation. If you look at Mercedes-Benz and BMW and even Lufthansa Airport, they had a plan for installation of 5G. So Europe is more of moving on to discrete manufacturing, and the second is onto mining. And when we look at it in North America, the market is more onto mining area, and also electric power transmission and distribution areas. And we also see oil and gas field in North America. And when we look at into Asia, Asia is also completely closely following by Europe market, which means we see more on discrete automation area, use cases in the Asia. When we look at into Asia, we see a lot of automation companies partnering with telecom companies, and also the network infrastructure companies, and they're already Mitsubishi Electric and Fanuc. They've already installed 5G trial cases in testing automated guided vehicles and so on for the initial adopters of 5G. With that, I move on to my colleague David to give recommendations.
All right, thanks, Naresh. We have a set of recommendations. Before I show you the list, I just want to maybe make our own little shopping list of things that have to be considered or cleaned up here. If you're an industrial user and you're looking to get into 5G, there's a list of things that still have to be finished or considered. First of all, like I mentioned, we're waiting for release 17. We just had release 16 get published about 2 months ago. And assuming things are on schedule, they tend to be a bit behind schedule. We don't expect this until 2022. Once release 17 is out, the next thing we have to wait for is the chipsets that we need. Probably similar to with what we went through with industrial Ethernet, we might have industrial grade chipsets by certain chip makers, and they have to be designed. They have to go through the stages of FPGA, ASIC, etc. until the chips are available on a wide scale and at an affordable price to put into our devices.
Allocation of frequencies, when we look at, as we discussed on the frequencies area, regulations and the governments are the key enablers of the allocating frequencies in individual countries. When we talk about global market, when some countries do not allocate frequencies for industrial usage, or for that matter, even in deploying entire 5G, moving on from 4G to LTE 4G to 5G, if the allocation is not there on frequency, then it's a kind of an inhibitor for 5G. So that's all on allocation of frequencies, which is a very key enabler for 5G.
Okay, and finally, we like to see our languages represented. As industrial users, we want to see the implementation of the protocols that our devices are used to speaking. That certainly involves CC-Link, Profinet, EtherCAT, Modbus, the typical ones, Ethernet IP, more and more OPC UA. And we also want to see, and this is actually being worked on right now, is the implementation of our time-sensitive networks which is a necessary, important timing mechanism for closed-loop control. There are industry providers already selling solutions that use 4G. You don't see them a lot, but they're out there. We were surprised in our research that we came up with so many. And these companies are not waiting. They're out there developing their roadmaps to extend 4G into 5G in the industrial space as soon as these 4 items, at least at the top there, are checked off. So to get to our recommendations, 5G is really a game changer. And that means it's important to reevaluate your current strategy for using networks and to figure out where 5G fits in. It's important if you're a product or a solution provider to develop a roadmap and to communicate this roadmap for 5G to your customers so they know what to anticipate and to get them used to the idea that 5G is coming. It's important this is one of my favorite ones, is to create awareness among users of 5G by talking up applications. Tell them about the applications that this is going to either enhance or make possible, things that we couldn't do before because it just wasn't possible with previous technologies. Help your users identify those particular applications at their sites and help them explore and discover new business models that, again, that weren't possible in the past, things that 5G can actually create or enable. We were a little bit surprised how important it is in our research. We discovered to partner with the companies out there, the network equipment providers, the chip makers, the carriers. This takes on a new meaning in 5G. Everything else in the past was something that a lot of end users, maybe with one partner, could implement themselves. This technology, 5G, requires more partnerships. And finally, show off, show what you know, position yourself, your company as a visionary and a technology leader in industrial 5G. I want to finally, this is actually my last slide, I promise, to draw your attention to the research that I've referred to that my colleague Naresh conducted this year with some support from me. This is a new market study from ARC. It is on the potential, with including market sizes for 5G used in the industrial space. Naresh, can you say a couple of lines about
sure,
the study?
David, as my colleague David said, it's a report on emerging market analysis report for industrial 5G. Our primary idea is to identify, what would be the market for 5G when 5G is available for the industry space. Then, when we dig on to research, then we identified LTE is already there in the industry. So our report includes LTE, and based on the LTE market, then we decided how the companies wanted to roadmap and when the roadmap could take place. So based on that, we estimated a 5G market. This report includes a forecast by region, hardware, and even software, and discusses about strategies for success for the user companies who like to deploy private networks, and also strategies for success for telecom operators and even network infrastructure providers, and so on. And even identify some addressable market scenarios and potential applications. If you look at the pie chart here, we try to understand from ARC has been in the automation field since 37 years. So we try to understand what could be the applications. Addressable applications could can adapt 5G. Primary initial adapters. Then when we look at it, that we identified that robotics markets and the smart sensors, field instruments would be the primary adapters, and even augmented reality. And when we look at the market, addressable market size, it looks over $30 billion US for base year 18. And we also identified some key list of suppliers in the report.
Hey, and let me point out something that you didn't mention. If you look at the bar chart on the lower right-hand corner, that's basically the market as we see it. This study is what we call an emerging market analysis report. It looks into the future for a technology that isn't quite there yet. So this is more our speculation and forecasting of how we think the market's going to develop. But it's kind of hard with a technology that isn't quite there yet. If you look at the green bars for 5G, we don't expect revenue until 2022, and we expect it to grow after that. My colleague Naresh had a moment of brilliance when he started this research, and he decided to include 4G because we think that logically 5G is going to build on top of 4G. In other words, the suppliers out there that have a foot in the market in 4G are going to be obviously the first movers that will migrate to 5G. We expect 4G to continue to grow in the market, as you see, but 5G is going to start in about 2 years and is going to build on 4G on top of it and take the market into the future. This is all included in the market study report that we're talking about. If you're interested in it, you can contact our colleague Rene Killias. His address is on the slide here. That's his smiling face. The three of us are located at ARC in Germany. Rene is up in Düsseldorf, I'm in Munich, and Naresh is in Dresden. If you have any questions about the topic, or if you're interested maybe in a copy of the slides, please write to Rene, send him a quick email, and we'd be happy to help you. We're finishing very close to on time. We're just barely breaking into the lunch break today. I want to thank Naresh really for your great efforts and the fantastic study that you produced, and also for being here today to share the information. And I would like to thank the participants, our attendees, for joining us for this quick half-hour update on industrial 5G right before the lunch break. Thanks very much. Thanks for attending, and enjoy your day.